If you've ever shaken a can of soda, then you know that when carbon dioxide bubbles leave a liquid quickly, you can get a violent eruption. The same thing happens at volcanoes, especially when the magma or molten rock can pick up extra carbon dioxide from the rocks that it passes through on the way to the surface. My research investigates how this process happens and exactly how much extra carbon dioxide the magma can pick up. Since this process is happening 10 miles underground, I make my own magma in a lab using a giant $1 million pressure cooker. Then I freeze my homemade magma into a solid to trap the bubbles, like a bug in amber, and look at it using a special $1 million microscope that sees in chemistry rather than colors. My research has found 3 different ways that magma can release the carbon dioxide previously trapped in the rocks. First, the magma can consume the rock like Pac-Man, as happens at Mount Etna in Italy, which releases the most carbon dioxide of any volcano in the world. 2, the magma can heat water around it, like at Yellowstone's geysers, and this dissolves the rock, similar to pouring coffee over a sugar cube. Third is it releases heat, and this heat can essentially boil the rock around it. Today, these 3 processes are only happening at a few locations around the world. However, therefore, humans are actually the significant contributor of carbon dioxide, a greenhouse gas, to the atmosphere on the order of about 8 gigatons per year. That's 9 zeros, or the weight equivalent of 4 billion cars. However, 65 million years ago, when the carbon dioxide content of the atmosphere was twice what it is today, there were no humans, only dinosaurs, and a lot of volcanoes that were stealing carbon dioxide from the rocks that they passed through. By my estimate, these processes could have released as much as 1 trillion tons, that's 12 zeros, of carbon dioxide into the atmosphere every year. This might explain why T-Rex lived in a tropical, fauna-filled sauna. So, since climate models are calibrated on the past the same way that a new watch is set to the time of an old watch, my research shows that this extra carbon dioxide source, this soda foam, needs to be included in these climate models in order to accurately predict our future and our own future sauna.